And for podcast number 34, we have this differential equation that y prime equals y minus y squared. And this is a separable differential equation, so we can separate and get all of the y's on the left side and all of the x's on the right side, and then be able to integrate. So I start by saying y prime can be rewritten as dy over dx. And I can see in the future I'm going to need to factor this. So I'm going to go ahead and factor it right now. I could factor out a y, and it leaves 1 minus y. And then divide both sides by this y minus 1 minus y, and also multiply both sides by dx. So all of the y information is going to be on the left side. And on the right side is just going to be dx. And now that we have separated the variables, then say integrate this side and integrate this side. So the right side is easy. That's just going to be x plus c. On this side, we're going to use partial fractions. So partial fraction decomposition. So what I think I'll do is just get a separate piece of paper and do that part. So if we have 1 over y and 1 minus y, then that can be rewritten as something over y plus something over 1 minus y. And then we'll just take a break from this calculus part and we'll do this pre-calculus part here. So then you can multiply both sides by the common denominator. So multiply by y and 1 minus y, and then do that for each term. And then there's lots of things that cancel. All of this is going to cancel all of this, leaving just a 1. Over here, the y's are going to cancel, so it's going to leave a times 1 minus y. And then the 1 minus y's cancel here, so it just leaves by, or b times y. And then we could pick numbers for y, like y equals 0 would be easy. That would leave 1 equals. And if y is a 0, this is just a times 1. And this is going to go bye-bye because b times 0 will be 0. So that was good. A equals 1. Next, we could pick another number, like it would be nice to have y equals a 1, because this then would become a 0. So the left side would still have 1. Then this would be a times 0, so that's 0. And this would be b times 1, so that's just b. So it turns out that the a is 1 and the b is 1. So we get the a over the y, and we get the b over the 1 minus y, just going back to these two. Okay, so now I'm done with the pre-calculus, so I'll transfer that back to the calculus part. So that means that this integral can be rewritten as integrate. We got 1 over y, and then it was plus 1 over 1 minus y. And then I could just move the dy over to the side like this. And the antiderivative of 1 over y will be the natural log of y plus the natural log of 1 minus y. But on this one, don't forget the chain rule. The derivative of the inside would be a negative 1. So then you need to divide by negative 1, or you can multiply by negative 1. And on the right side, it would be x plus a constant. And then how do we solve for y? Well, using e seems like a good idea, except there's this plus minus in between. So then we need to go back to pre-calculus and go, if you have natural log of a over b, then that's going to be the natural log of a minus the natural log of b. Or if you have two logarithms that are being subtracted, you can change it into one logarithm as long as you divide the two things. So back to this. So this is subtraction. So you can change this into one logarithm as long as you then divide them. And for now, the right side just stays x plus c. And now we could eliminate this natural log by exponentiating both sides. And over here, these will cancel, and it's going to leave y over 1 minus y equals the e function. And then we can even plug in the numbers that are given, that if x equals 0, y is equal to a half. So if x equals 0, then this would be 0 plus c, so that's just c. And then y will be a half, so 0.5 over 1 minus 0.5. And this 1 minus a half is a half, so a half divided by a half is just a 1. So e to the c is equal to 1. And then what I would do is over here on the right side, just rewrite this as e to the c times e to the x, and then replace e to the c with a 1. So just use the property of exponents to rewrite this one this way, and then we'll replace the e to the c with a 1. And then we've got y over 1 minus y, and then replace e to the c with a 1. So that's just 1 times e to the x, or it's just e to the x. And then I'm wondering if we can get creative with the algebra so we can just solve for y and have it say y equals rather than this right here. Well, I think that what I'll do is invert both sides. So for that, I'm going to need some more paper right here. So I'll invert this side so it becomes 1 minus y over y. The reason for doing that is I can then see this can be broken up into two fractions, 1 over y and then minus y over y. And minus y over y is going to simple very nicely. So that's how come I thought of doing this. When you invert this side, you can say that it's 1 over e to the x. Or in the next step, you could just say this is the same thing as e to the negative x. And then on the left side, I can break this up into two fractions. So it would be 1 over y minus y over y equals the e to the negative x. And then reduce this, it becomes just a 1. So we have 1 over y minus a 1 equals the e to the negative x. And then we just have two more steps to solve for y. One would be add 1 to both sides. So add 1 to both sides. And then finally, invert it again. So if you invert the left side, it becomes y over 1, or just y equals. And then on the right side, invert it so it becomes 1 over e to the negative x plus 1.